So one of the important skills that we are working on and developing that comes up later when we have to solve equations with logarithms is writing things as a single logarithm. So whenever something says write an expression as a single logarithm, you're looking at your log laws and you're always wanting to move from the right-hand side to the left-hand side. Because in all of our log laws that are listed on our formula sheet, on the right-hand side, it's a single log. On the left-hand side, it's either adding, subtracting, or a log that's being multiplied by something. Now, when you get multiple log laws in one question, which these ones have, when we get multiple log laws in one question, we have to decide which log law are we going to use first. For example, in the first one, we've got log x plus 3 log y. You can see that there's the adding there. That's one of our log laws. We also see that there's a number in front, and that's one of our log laws. So in the decision to decide which of these two should I use first? The one that multiplying that says it's adding, or when there's a number in front that I can move it in as an exponent. Well, an important thing to look at with these formulas, if I look at my first formula here only works if it's a log plus a log with the same base. This formula doesn't say I'm allowed to have any extra numbers in front. And so in question A, the fact that I have an extra number in front here to start with means that I can't use that first log law yet. Because that first log law only works if it's one log plus another log with the same base. So in starting A,
The following individual with the black Camaro with the license plate HNP614 and the two other vehicles that are also parked beside it.
so the first thing is we'll move that 3 out in front in as an exponent.
The other license plate that needs to come to the
All right, and then once you've moved that number up in as an exponent, now we have a log plus a log. And so we can combine them by multiplying them together. And what's inside the one is the x, and what's inside the other one is a y cubed. So when we put them together inside the log, we'll have x times y cubed. Part B, we have a number of things happening here. We have a log plus a log, subtract a log with numbers in front. So we're also having, if we're doing a list here and calling this one a second log law, we also have the third log law here, which says if you're subtracting two logs with the same base, that's the same as dividing. Now, that third log law with the dividing has the same stipulations as the first one. It only works if it's one log, subtract one log. So we're going to notice that when we want to combine things as a single log, we will always be looking at the power law first. We'll always be looking, if there's any numbers in front, the first step that we're going to do is we're going to put those inside the log as an exponent. So in this one, do we have numbers in front? Sure, we do. So our first step is we're going to put that 2 in as an exponent, and we're going to put that 4 in as an exponent. Now we have a log plus a log and a log minus a log. So the question is, well, which should we do first? Does it matter which one we do first? How are we going to work about this? Well, it won't matter which one you do first, because A law is a law, so if I want to do the subtracting one, it's there, I could do that. If I want to do the adding one, it's there, I can do that. And eventually what we're going to do in this is we're going to put them all together all in one step, okay? Because whatever is adding is going to be multiplied, and whatever is subtracted is going to be divided. So as our shortcut in doing this all at once, we're going to say, well, whichever ones are positive, they will be multiplied together on the top of our fraction. Whichever one is subtracted will be divided. If you wanted to do this in 2 steps, you could put the first 2 together and get x times y squared inside one logarithm. And then you'd have the subtracting. So your x times y squared would be on the top, and your z to the 4 would be on the bottom. But we're going to find that, especially as ones get really, really big, it's nice to be able to just do this as one step. And you're going to be able to say, okay, so whatever is added is going to go on the top of my fraction, and whatever is subtracted is going to go on the bottom of my fraction. And part C here we looked at already when we did question 12 in the homework. Here we want to write that 3 as log 2 of something. So we're going to section off a little bit over here for thinking and say to ourselves, well, if 3 was equal to log 2 of something, what would that something be? And again, using your definition of a logarithm, the base is 2, the exponent is 3, the answer is x. You can see that that x has to be 8. And now we have a single log minus another single log. We can put that together as dividing. We can simplify it if we'd like. Ooh. I mean, if you wanted to have fun with this, I could make one nasty multiple choice question out of this. Because if I look at this and I use my log laws, does it make sense that that's equal to log 2 of 3 minus log 2 of 4? Expanding it again. And log 2 of 4 is what? That one you can mental math. I mean, this is the final answer. This extra stuff that I'm doing now is just playing around with math, which is fun. But what is log 2 of 4? 2 to what power is 4? 2. Can you imagine a multiple choice question that says log 2 of 6 minus 3 is equal to which of the following? And the answer happens to be B, which is log 2 of 3 minus 2. And you have no calculator. Like, that looks nothing like what you, that would be if I was in a really bad mood and wanting to make a multiple choice question, that would be it. That's the kind of multiple choice question I'd put on a grade 12 math contest. That'd be a fun one. But I won't do that to you on your quiz or test. But it would be fun to do if you knew the right answer. I guess it would be a legitimate question. I could give you that question if I told you the answer is B. And have fun with it. See if you can figure out how. Then it wouldn't be so bad. Then you wouldn't be mad at me. Okay. So these ones are similar to what we did in question 1, but now we're introducing variables. So it's the same kind of idea, writing as a single logarithm, but now we're introducing variables.